So today we're going to be looking at radians. Now radians might be something that is completely new to you. Radians is a way of measuring the angles in circles, or just angles in general really. So the Babylonians, think of a circle. The Babylonians are who we have to thank for giving us the 360 degrees system of measuring angles in a circle that we have. Ancient astronomers had been observing the skies, and they observed how the passage of the sun through the sky seemed to change by about 1 degree each day, and therefore that led to the solar year as 360 days. The Babylonians studied circles extensively, and they came up with a circle having 360 degrees. 360 degrees is quite a nice number to work with because it has many factors. However, we can also use radians to measure angles. Mathematicians say that this is the natural unit of angular measurement. And as you will find out, that often when we deal with radians, we'll have radians written as a fraction of pi, and pi is a number that appears all over the place in mathematics, but also in physics and in right down to a cellular, molecular level. So if you're dealing with a lot of these different calculations and you've got a number which is a fraction of pi, it makes your calculations a lot easier. So let's have a wee think about a circle. So we're going to think about this circle here, and here's its centre O, and we've got radius R, and we've got radius R here on these points A, B, and now we've got this length, this arc length, and this arc length we've made to also be R, so it's like almost like a triangle of a sector. And when we have a sector where the radius is R, the arc length is R, we say that the angle here is 1 radian. And we've got 1 rad. So this is the angle is 1 radian, which is sometimes written as 1 rad. Now, this is important to note that sometimes no symbol is used for radians. Sometimes, not always. If that's the case, it'll be in a situation where you know that they actually do mean radians. So let's think about this little problem more deeply. Let's think about the size of an arc length is equal to 2 pi r, which is our circumference, and then we times that by theta, the angle, over 360. Now, in our case, the arc length is r, and we've got 2 pi r theta over 360. Now, the r's can cancel, and let's bring the 360 over here. Now, remember, theta is, we've already said theta is 1 radian. So theta equals 1 radian. So 360 equals 2 pi radians, which means pi 180 is equal to pi radians. Since this is the case, we can also think of, that would give us 90 degrees would be pi over 2 radians, and 45 degrees would be pi over 4 radians. So by defining it this way, you already see how, when we're dealing with something in radians, 360 degrees we would say is 2 pi radians, 180 degrees is pi radians. And you can see how if we were to use these in calculations, how they would be much simpler. So our rule is to change from degrees to radians, we multiply by pi over 180, and to change from radians to degrees, we multiply by 180 over pi. And it is useful to note that if we were to look at this, if we were to actually go back to here, where theta, what we've said theta is 1 radian, but if we were to actually go theta equals 360 over 2 pi, you would find that theta actually is round about 57 degrees. So 1 radian equals round about 57 degrees. So that's just useful. So that's something that's useful just to kind of lodge in the back of your mind. Now let's look at a couple of examples. Let's change 30 degrees to radians, and we give in terms of pi. So we know that 30 degrees would be times by pi over 180 to get radians. 180 and 30 can be simplified to pi over 6, and that's it, pi over 6 radians. Now we want to do the opposite. We want to change 5 pi over 9 to degrees. So we're going to take our 5 pi over 9 and this time we'll times it by 180 over pi. So we can see the pi's are going to cancel, and 180 divided by 9 is going to give us 20. That's going to cancel there, that's going to give us 20. 20 times 5 is 100, and that's going to be degrees. And finally, it's just really helpful to just to memorize some simple, some very useful conversions, so you don't have to actually calculate them, that you'll just always be wanting to pull out and use in calculations. So 0 degrees is the same as 0 radians. 30 degrees, we've already had, is pi, over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2, and 360 degrees is 2 pi. So I hope that helps.